Okay, here's warm-up number 50. How long would it take for $100 to triple if invested at 4% annual interest? So annual interest. So we just need our basic exponential growth formula. You could do the one with the ends, but the ends would both be ones since it'd be compounded once per year, and it'd simplify to this anyways. Okay. All right. So let's start plugging this stuff in. 100 is my initial amount. Since it's going to triple, my final amount then is going to be 300. The rate is 4%, so written as a decimal, 0.04. The only thing I don't know is the time. Okay. So let's divide both sides by 100. Let's do that. And then 3 is going to equal 1.04 to the t. I just combined those, right? All right. And now from there, I need to use log form. So my base is going to be 1.04. 3 is going to be the contents of the log, and then the t gets isolated. And then I'll go to my calculator. So in my calculator, since I can only do base 10, I'm using change of base formula like this. Okay, so I'm going to do log of 3 over log of 1.04. So, that number goes on top, that number goes on bottom, that number's lower, right? So that's how I remember which one's on top, which one's on bottom. All right, log of 3, close your parentheses, divided by log of 1.04. And then we've got about 28.01. That many years. Okay. All right. Next up, let's solve this equation for x. So before we combine these two logs, these both have the same base. They're log base e, so we can combine them. But before you combine them, you need to move the coefficients up into the exponent position using the power rule. So this is going to be the natural log of x squared plus the natural log of 4 to the third. Okay, 4 to the third, I can simplify that. That's going to be 64, right? Yeah, 64. So we've got natural log of x squared plus natural log of 64 equals 8. Okay, and then when I combine these logs, I can, when you're adding two logs with the same base, you just multiply the contents together. So this will be the natural log of 64x squared. And that's all going to be equal to 8. Okay. Now at this point, I'm going to have to put this in into exponential form. So think of this as a log. Log base e of 64x squared equals 8. So my base is e. 8 is going to be the exponent, and then I've got 64x squared. So I'm going to put e to the 8th in my calculator. So I hit second natural log button to get that. Okay, so 2980.96 roughly equals 64x squared. So next step, I'm going to divide by 64. Okay, and then I've got 46.58 roughly. Here, I'm running out of space here. Okay, and the last thing would be to take the square root of both sides. Okay, and that's going to come out to about 6.82. Okay, now you could say positive or negative if we're just looking at this algebraically, but you can't have a negative content to a log right there, so we're just going to use the positive root. So 6.82. I'm going to go to the nearest hundredth. Okay. All right, last one. We're going to switch the x and the y to find the inverse here. We're finding the inverse of this. So that's kind of my y, right? Switching that to x. And now I'm going to solve for y. So I'm going to subtract 5 from both sides first. Okay, now I'm going to have to put this in log form to isolate the 3y. My base is e. The contents would be the quantity x minus 5. The 3y gets isolated. Hey, that's a natural log, so let's rewrite that as the natural log of x minus 5 equals 3y. And then the last step is going to be divide by 3. Okay, and the very last step, I guess, is to put it back into function notation. So the inverse of that function is that fraction there. Okay, and that's it for this warm-up. See you next time.